discuss how to solve games by linear programming. That is linear programming solution of games. Say player A has M strategies, that is A1, A2, so on up to AM, and player B has N strategies, that is B1, B2, so on up to Bn. Now, this is the payoff matrix corresponding to A1 strategy. Payoff is A11, A12, and so on A1n. Corresponding to A2, payoff is A21, A22, so on up to A2n. And corresponding to strategy AM, payoff is AM1, AM2, so on up to AMN. Now, let us assume that player A picks strategies A1, A2, so on up to AM with optimal probabilities x1, x2, so on up to xn. Here, player A picks strategies A1, A2, AM with probabilities x1, x2, so on up to xn. Then players A's optimal probabilities, that is values of xi's, can be determined by solving this program. This is based on best of worst criteria. First we choose worst and then we choose best. For worst position, the minimize of this thing, which is a11 x1 plus a21 x2 plus so on up to am1 xn. If we write this in closed form, this becomes I varies from 1 to m a I1 xi. Here 1 is fixed and this coefficient is varies. Therefore, summation I is equal to 1 to m a I1 xi. This becomes, if we open this becomes a 1 1 x1, a 2 1 x2 plus a 3 1 x3 plus so on a m1 xn. And the next term is a 1 2 x1 plus a 2 2 x2 plus so on a m2 xn. This in closed form becomes summation I is equal to 1 to m a I2 xi, and we continue in this way. We get summation I is equal to 1 to m ai n xi. We take minimum of this. This gives worst position. Then to choose best, we maximize this over xi. Subject to the condition that sum of probabilities equal to 1, that is x1 plus x2 plus so on up to xm equal to 1. We know that all probabilities are greater than equal to 0. Therefore, xi's are greater than equal to 0 for I is equal to 1 to m. Now we change this program into linear program. For this, let us assume the minimum value of these is v. That is, v is equal to minimum of these values. As v is minimum of these values, therefore v is always less than equal to for all of these values. That is, v is less than equal to summation I is equal to 1 to m a I. Here 1, 2, 3, 4 up to n, we represent it by j. Therefore, b is less than equal to summation I is equal to 1 to m a I j xi, where j varies from 1, 2 up to n. Using this, in this program becomes as player A's linear program is, we have to maximize this value and we consider minimum of this as v. Therefore, maximum z is equal to b, our objective function, subject to the condition. From this we get the condition v minus this thing less than equal to 0. Therefore, b minus summation I equal to 1 to m aij xi less than equal to 0 for j varies from 1 to n. For j varies from 1 to n. The sum of probability is 1, that is x1 plus x2 plus so on up to xn equal to 1. All probabilities are greater than equal to 0. Therefore, xi greater than equal to 0 for every I varies from 1 to m. And because b is the minimum value of this and moreover value of game, this can be negative, positive or 0. Therefore, b is unrestricted. Therefore, this becomes player A's linear program. Now, let us consider that player B mixed strategies B1, B2, so on up to Bn with probabilities Y1, Y2, so on up to Yn. Player B's optimal probabilities Y1, Y2, Yn are determined by solving the following problem. This is also based on best of worst case criteria, but as payoff matrices of player A, that is expected payoff matrix is of player A, therefore we have to first maximize and then minimize. Minimize over yj and maximize the value of this a11 y1 plus a12 y2 plus so on a1n yn. Here one first component is fixed. If we write this in closed form, this becomes j varies from 1 to n a1j yj. This, if we open this expression, this becomes a11 y1 a12 y2 plus a1n yn. And similarly for other expressions, the next is a21 y1 plus a22 y2 plus so on a2n yn. In closed form it becomes j varies from 1 to n a2j yj. So on am1 y1 am2 y2 plus amn yn. This expression in closed form becomes summation j is equal to 1 to n amj yj. We have to maximize, we have to choose maximum of this and then take minimum value of this thing. As y1, y2, yn are probabilities, and we know that sum of probabilities is 1, therefore subject to the condition y1 plus y2 plus so on up to yn equal to 1. All probabilities are greater than equal to 0. Therefore yj greater than equal to 0 for every j varies from 1 to n. Now to change this problem into linear program, we take maximum of these values, say v. V is maximum of these values. As v is maximum of these values, therefore v is always greater than equal to all of these. That is, v is greater than equal to summation j is equal to 1 to n aij yj. I varies from 1 to so on up to m. Therefore v is greater than equal to summation j is equal to 1 to n aij yj, where I varies from 1 to m. Now we use this expression in this problem. Using this in this equation, as this is minimum of maximum of these and we assume maximum of these as b, therefore this program 1 becomes minimum w is equal to v subject to the conditions b minus this thing greater than equal to 0. This becomes v minus this summation j is equal to 1 to n aij yj greater than equal to 0 for every I 1 to m. And sum of probabilities equal to 1, that is y1 plus y2 plus so on up to yn equal to 1. All probabilities are greater than equal to 0, therefore yj greater than equal to 0 for every j varies from 1 to n. And because v is the maximum value of this and moreover v is value of game, therefore it can be negative, positive or 0, therefore v is unrestricted. This becomes player B's linear program. Now this is player A's linear program and this is player B's linear program. We already discussed how these programs are established. After solving player A's problem, A's linear program, we can find the values of probabilities x1, x2, so on up to xn, and after solving player B's linear program, we find the value of probabilities y1, y2, so on up to yn. Moreover, we find the value of game. Now I am going to discuss how to write linear programs for the games. Consider this example. Write the linear programs of player capital A and capital B for the following 3 cross 3 game. Player A has 3 strategies A1, A2, A3. Player B has 3 strategies B1, B2, B3. This is the payoff matrix. Say player A mix strategies A1, A2, A3 with the probabilities x1, x2, x3, and player B mix strategies with the probabilities y1, y2, y3. Then player A's linear program is maximum z is equal to v minus 3x1 minus 2x2 minus 5x3 less than equal to 0. On solving this, we get v minus 3x1 plus 2x2 plus 5x3 less than equal to 0. The second constraint is v minus x1 plus 4x2 minus 6x3 less than equal to 0. On solving this, we get v plus x1 minus 4x2 plus 6x3 less than equal to 0. The third constraint is v minus 3x1 minus x2 plus 2x3 less than equal to 0. On solving this, we get v plus 3x1 plus x2 minus 2x3 less than equal to 0. Sum of probabilities is 1, that is x1 plus x2 plus x3 equal to 1. All probabilities are non-negative, therefore x1, x2, x3s are greater than equal to 0, and value of game is unrestricted, that v is unrestricted. This is the player A's linear program. After solving this linear program, we will get the values of x1, x2, x3. If someone asks to find or to solve the following game by linear programming, then first we write its linear program and then we solve this linear program. As we already discussed to solve the techniques of linear program, therefore I am not going into much details that how to solve this linear programs. These linear programs can be solved by simplex method, Big M method, or two-phase method. The appropriate method which can be used to solve this problem. Player B's linear program is to minimize W equal to V, subject to the conditions V minus 3y1 minus y2 minus 3y3 greater than equal to 0, which on solving becomes v minus 3y1 plus y2 plus 3y3 greater than equal to 0. Similarly, we can write these two constraints v minus 2y1 plus 4y2 minus y3 greater than equal to 0. On solving this, we get v plus 2y1 minus 4y2 plus y3 greater than equal to 0. The third constraint is v minus 5y1 minus 5y1 minus 6y2 plus 2y3 greater than equal to 0, which further gives v plus 5y1 plus 6y2 minus 2y3 greater than equal to 0. Sum of probabilities equal to 1, that is y1 plus y2 plus y3 equal to 1. All probabilities are greater than equal to 0. Therefore, y1, y2, y3 greater than equal to 0, and v value of game is unrestricted. This is player B's linear program. After solving this, we get the values of probabilities y1, y2, y3. Sometimes it can be asked to find the range of value of game. Then one important remark is here that value of game is always lies between max min value and min max value. That is, max min values is less than equal to value of game, less than equal to min max value. Now say we find the value of game, the range of value of game for this program, then first we find the min max value. First we find row minima. Minimum value of corresponding to this row is minus 3. Then corresponding to this row is minus 2. Then corresponding to this row is minus 6. And after that we will find the maxima of this. The maximum of this is min max value. This is First we find the row minima. Now we find the maximum value of this. This is maximum value of this. Now we find the column maxima. Column maxima is maximum of this column is 3, maximum of this column is 4, and maximum of this column is 2. Now we find the min max value. The min max value is this. Therefore, according to our remark, value of game is always lies between maximum value to min max value. In our case, maximum value is -2 and min max value is 2. Therefore, value of game for this problems lies between -2 and 2. Therefore, value of game lies between -2 and 2, including -2 and 2. Therefore, we can find the range of value of game with the help of this remark.
Friends, if you like this video, please subscribe our channel. For notification of new videos, please click on bell icon button. Thank you friends. Keep watching our videos.